Quantum in finance is not one story. It is a portfolio of initiatives across optimization, risk, trading, and security, with partnerships often doing most of the heavy lifting. Here, I will give you a structured snapshot of what banks and financial institutions have actually published on quantum over the last few years. Think of it as a map, not a ranking. Each initiative is placed in a simple grid. Vertically, you see the business domain, so where in the bank the work sits, for example, credit risk or portfolio allocation. Horizontally, you see the quantum method, the technical approach behind it, for example, QAOA or quantum machine learning, or post-quantum cryptography as a program. The goal is to provide a grounded view of what is really happening in the market. This is not exhaustive. If I missed something, or if you disagree with how I categorized an initiative, please let me know. You will find my email at the end of the video. Before we go into the grid, a quick note on the quantum method and topic labels you will see on the columns. These names can look technical, but for this overview, you only need the one-line intuition and the key limitation. Quantum annealing is a specialized approach to optimization on annealing hardware. It is mature from an availability point of view, but it is not the same as universal gate-based quantum computing, and mapping real bank constraints into it can be limiting. QAOA, the quantum approximate optimization algorithm, is the best-known gate-based optimization method in the NISQ era. It is attractive because it is hybrid and flexible, but for realistic problem sizes, it quickly runs into qubit and circuit depth limits, and performance can be sensitive to noise and parameter tuning. Quantum Monte Carlo and amplitude estimation are interesting because, on paper, they offer a meaningful speed-up for estimation problems, the kind of thing you see in derivatives pricing and risk. The catch is that full advantage typically needs fault-tolerant machines, so today you mostly see iterative or QAE-light variants. On the machine learning side, you will see three buckets. VQC, variational quantum classifiers, are hybrid models built from a small trainable circuit plus a classical loop. QSVM, quantum support vector machines, use quantum feature maps and kernels. And the general QML category covers other hybrid quantum machine learning approaches beyond VQC and QSVM. Across all of these, work is typically proof of concept today, and advantage over strong classical baselines is often unclear. You will also see a category called Other. That is simply a practical bucket for publications that do not disclose the exact algorithm, or that use hybrid or quantum-inspired methods where the quantum part is not clearly specified. Finally, QKD, quantum key distribution, and PQC, post-quantum cryptography, are security topics rather than compute algorithms. QKD uses physics-based links to distribute keys for secure communications and has production deployments, but it comes with constraints on distance, rate, and specialized hardware. PQC is a classical cryptography migration program designed to protect long-lived confidentiality and authentication against future quantum attacks. It is recommended to start now, but it is a multi-year cross-enterprise change effort. Read the columns as method and topic families with very different maturity levels. Some are near-term proof of concepts, and some are already operational security programs. Now let's go into the grid and walk through the timeline. We start with 2021 and earlier, when most activity was still exploratory, and then move forward year by year to today, where patterns in priorities, partners, and maturity become much clearer. Before 2021, the earliest bank-adjacent deployments are often security-led, not compute-led. A concrete example is that ID Quantique and Mount Pelerin partnered on a QKD-based quantum vault concept for digital asset custody. That partnership is publicly dated to 2019. By 2020, banks like BBVA publicly communicated a structured approach, alliances plus internal capability building, not only isolated proofs of concept. Also around 2020, BBVA worked with Fujitsu on a portfolio-style optimization proof of concept using the digital annealer approach. This is a good example of quantum-inspired methods moving faster toward production discussions. In 2021, we see the two-track pattern clearly. Optimization research and development on one side, and field trials in quantum-safe communications on the other. On the security side, A well-documented field milestone is the quantum safe data transfer trial at Danske Bank, framed explicitly as moving quantum communications out of the lab. In 2022, the story shifts from pilot curiosity to more repeatable pipelines. On the research side, the Bank of Canada published work on quantum Monte Carlo for economics and stress testing, which matters because it maps quantum methods onto problems finance actually budgets for. On capability building, Credit Mutual Alliance Federale launched a quantum readiness discovery phase with IBM and joined the IBM Quantum Network, which is a classic signal of multi-year intent. In 2023, partnerships start to look like real operating models. HSBC ran a QKD-related trading protection trial positioning quantum cryptography as protection for sensitive FX trading workflows, with partners including BT and Toshiba. Credit Mutual Alliance Federale publicly extended its program with IBM, reinforcing that quantum capability building is being treated like a portfolio, not a single use case. On applied optimization engineering, the Rabobank and TNO ecosystem is visible publicly, including portfolio optimization content and publications. In 2024, the security track becomes operational because standards and coordination accelerate. A hard trigger is that NIST finalized the first 3 post-quantum cryptography standards in August 2024, which converts PQC awareness into procurement and migration roadmaps. On cross-sector coordination, Europol EC3 created the Quantum Safe Financial Forum, and major financial institutions publicly joined. That is an alliance model for PQC transition governance. On the optimization credibility side, 2024 also features high-visibility research around QAOA performance and scaling arguments, which finance teams use to justify continued experimentation budgets. And on central bank infrastructure, BIS Project LEAP frames PQC as a system problem, focusing on hybrid deployments and crypto agility lessons. In 2025, the landscape becomes dense, and 2 themes dominate: production-adjacent evidence and industrialization vehicles. On evidence, HSBC and IBM reported a quantum-enabled algorithmic bond trading trial, with HSBC publicly citing up to 34% improvement on a specific prediction task. This is the type of result finance audiences pay attention to, even while treating it as early and context-specific. On portfolio construction, IBM and Vanguard published a collaboration on variational quantum approaches for portfolio optimization, another example of asset management grade interest. On cybersecurity consortium execution, MAS coordinated a QKD proof-of-concept sandbox with DBS, HSBC, OCBC, UOB, SPTEL, and Spectral, and published a technical report. This is what sector-scale partnering looks like in practice. On PQC infrastructure, BIS Project LEAP Phase 2 pushed into payment system constraints and deployment realities, a bridge from lab cryptography to operational architecture. A key point is that SC Ventures and Fujitsu formed a joint venture incubated as Project Quanta, explicitly aiming to integrate quantum resources and talent on a platform. This kind of joint venture is designed to increase throughput of pilots, publications, and partner onboarding. Finally, on PQC pilots with real regulatory data flows, Banque de France and Allianz reported an experiment securing regulatory file transfers using PQC on OneGate, with CryptoNext security referenced in the ecosystem. Given the 2025 joint venture and consortium structures, it is reasonable to expect more structured releases in 2026, platform roadmaps, additional pilots, and more published technical guidance, especially where partnerships already exist and governance is in place. From up to 2021 through 2025, the core pattern is clear. Banks rarely do quantum alone. The leaders are building ecosystems, moving from pilots to programs, and now creating industrialization vehicles, consortia, and joint ventures. To keep this transparent, I am also including the source index. Each row has an index number, the publication year, the entity, the business domain, the quantum algorithm or topic, the partners involved, and a direct source link. You can pause the video, pick any entry, and jump to the original publication. I'm not going to read all rows line by line. Instead, I will point out a few examples that illustrate the patterns. On the optimization side, you see portfolio allocation entries using QAOA or related approaches, often with major platform and software partners. For example, Citi in portfolio allocation with AWS and Classic. You also see JP Morgan Chase with a portfolio allocation entry, and Rabobank with published work in an ecosystem that includes TNO. On valuation and risk, there are derivatives pricing entries, for example, Goldman Sachs and later UBS. These are good reminders that much of what is published is still engineering validation rather than production deployment. On the machine learning side, you see domains like fraud and AML and customer retention with VQC style approaches. For example, Intesa Sanpaolo and Itaú Unibanco, and later Lloyds Banking Group. And then there is the security track, which becomes much more visible in the later years. You see QKD pilots and PQC transition programs, including the MAS-led QKD sandbox with multiple Singapore banks and industry partners. You also see BIS Project Leap, which treats PQC as a system-level infrastructure problem, not a single application upgrade. And there is the Banque de France and Allianz entry on securing regulatory file transfers using PQC. A particularly interesting trading example is HSBC, which appears in multiple places. There is the QKD-related trading protection trial with partners like BT and Toshiba, and there is the more recent HSBC and IBM work on quantum-enabled algorithmic bond trading. Even if you treat the results as early, it is a useful signal. Real workflows, named partners, and a published source link. So use these legend pages as a navigation layer. They make the grid transparent, and they let you validate and explore any item you find relevant. And to summarize the pace of activity, here is the cumulative view. This chart shows the cumulative count of published quantum initiatives in finance from 2021 to 2025, split into 3 tracks: quantum annealing, cybersecurity work around QKD, and post-quantum cryptography, and digital quantum computing proofs of concept. The big picture is the growth curve. Across all tracks combined, the cumulative total rises from about 9 initiatives in 2021 to about 42 by the end of 2025. Most of that increase is driven by digital quantum computing proofs of concept. You can see the green segment expanding steadily year by year, moving from single digits in 2021 to the low 40s by 2025. What also stands out is the security track. Cybersecurity activity remains modest through 2024, then shows a clear step up in 2025, which is consistent with the market shifting from awareness to more concrete PQC and QKD programs. So the takeaway is simple. The pipeline is getting denser, digital quantum work drives most of the overall volume, and security-related initiatives accelerate noticeably in 2025. If you want to go deeper on this, qubit-lab.ch supports organizations building practical quantum capability, from readiness and enablement through use case discovery and proof of concept execution. That includes education for leadership and expert teams, structured roadmap development, vendor navigation, and hands-on support to design and run credible proofs of concept. If this is relevant for your organization, you can reach me at contact@qubit-lab.ch. Thanks for watching.